Have you ever wondered why time seems to flow in one direction only? Why can't we go back in time and change the past? These are questions that have puzzled philosophers and scientists for centuries. In this video, we're going to explore the nature of time and try to answer the question of why time's arrow always points forward. Before starting, don't forget to subscribe to the channel. So sit back, relax, and let's explore the nature of time's arrow. The enigmatic dance of time, where our everyday experiences often collide with the hidden intricacies beneath the surface. Think about those moments when you're with friends, sharing laughter and stories, and the hours vanish like a fleeting dream, or when you're sitting in a waiting room, with the clock on the wall moving at an agonizingly sluggish pace. You find yourself yearning for the moment when time will finally set you free. We know time is ordinarily constant, but those moments seem to defy the laws of physics, where hours seem to shrink into mere minutes, or minutes seem to stretch to mind-numbing hours. Moments that seem to drag on. Time plays tricks on us. A few minutes can feel like a lifetime when you're stuck in traffic, the world outside your car window inching forward at a glacial pace. And yet, when you're with someone you love, time seems to fold in on itself, compressing entire hours into mere moments. Our experience of time is a fascinating paradox, one that scientists, philosophers, and poets have pondered for centuries. Physical concepts of time. The passing of time is not the only factor that affects how we perceive it. Our emotions, focus, and environment also play a role. Time, in the vast tapestry of existence, is a real force that intertwines with our lives. It is like an invisible current at the bottom of a serene lake, sometimes gently guiding us, and at other times, challenging us to swim against the tide. We have devised ingenious ways to measure time, from ancient sundials tracing shadows to today's atomic clocks, which are astonishingly accurate. So accurate they wouldn't have lost or gained a second if they had started running at the beginning of the universe. We've sliced years into months or weeks, and the day into seconds, minutes, and hours, allowing us to synchronize our lives with exquisite precision. If the video is informative for you, then like and share it with your friends. Also, remember to subscribe to the channel. Now, going back to the topic, but in the particular theory of relativity, Einstein proposed that time isn't absolute, ticking away uniformly for everyone, everywhere. Instead, it's relative, and its pace can change depending on how fast you're moving. Imagine two spacecraft, one hurtling through space at nearly the speed of light, while the other stays put on Earth. For the astronaut in the speedy spacecraft, time seems to slow down. It's as if they're in a slow-motion movie while the rest of us are in real time. This phenomenon is called time dilation, and it's a mind-bending concept that defies our everyday intuition. But that's not all. Einstein's general theory of relativity suggests that gravity itself can distort time. Near a massive object, like a planet or a star, time actually flows slower than it does in the emptiness of space. Think of it this way. You're standing near a giant planet, and I'm floating in a spaceship. For me, time passes normally. But for you, standing on that massive celestial body, time moves at a slower pace. What I experience as 1 hour could be a second for you. It's like a cosmic tug-of-war between gravity and speed, where time itself is the prize. To visualize this, picture a rubber sheet stretched taut, representing the fabric of space-time. Place a heavy ball, like a planet, in the center, creating a dip in the sheet. Imagine rolling a smaller ball, representing a spacecraft, along this curved surface. It will follow a curved path, mirroring how gravity bends the path of light and slows down time. Time's arrow. The concept of the arrow of time tells us that time has a unique directionality, a fundamental quality that distinguishes between what has happened, what is happening, and what is yet to come. In our daily lives, we experience time as an ever-rolling film, moments slipping gracefully from the past into the recesses of memory. We stand firmly in the present, where our actions have consequences, and then these actions flow into past, from what is happening to what has happened. But what about the future? It's shrouded in uncertainty, a realm where time's arrow points relentlessly forward, yet veils its secrets. We can anticipate, dream, and plan, but the future remains a realm of infinite possibilities, waiting to be unveiled. Entropy and time's direction. Entropy is a measure of disorder or randomness in a system. In simple terms, it is like spreading ink in a glass of water, where the ink molecules are dispersed until they are evenly mixed. Entropy increases in a closed system, a concept known as the second law of thermodynamics. Entropy increases are closely related to the passage of time. Think of it as a natural tendency for things to become more chaotic over time. Imagine a child's playroom filled with toys. At first, every toy has its designated spot, and the room is tidy. However, as the child plays, toys get scattered everywhere. This natural progression from order to disorder is like entropy. Just as it's easier for the room to become messy than for it to spontaneously tidy itself, processes in nature tend to move towards chaos. To get the room back to its original tidy state, someone, like a parent, needs to intervene and put in effort. Similarly, to reverse entropy, external energy or intervention is required. This one-way journey from order to disorder helps us understand the direction in which time flows. Thermodynamics and time's unidirectional flow. In the realm of thermodynamics, systems tend toward equilibrium, where the distribution of energy and particles is as evenly spread as possible. When you pour cream into your coffee, it swirls and mixes until it's uniformly blended. Reversing this process, like unmixing the cream from your coffee, requires extraordinary effort and often external energy. The key insight here is that natural processes, left to their own devices, tend to move towards a state of greater disorder and higher entropy. This natural progression is what gives time its unmistakable direction: forward. It's like a train on a track, always moving forward and never reversing. Metaphysical musings on time. The metaphysical musings of time are more than a scientific concept. Entropy is the force that controls time. Time's arrow reminds us that our past is the foundation upon which we build our future, and that each fleeting moment is a precious jewel in the mosaic of existence. Some argue that time is indeed a fundamental, immutable aspect of reality. It is the backdrop against which the cosmic drama unfolds, an essential thread woven into the fabric of the universe. In this view, time is as real as space, matter, and energy, which form the basis of our understanding of reality. On the other hand, there is the intriguing idea that time may arise as the consequence of deeper, more fundamental processes. Imagine the universe as a grand symphony in which the instruments of quantum physics play a melody that is time. It is a concept that challenges our intuition. Time is not a building block of the universe, but a beautiful byproduct of its complex dance. This question takes us to the heart of one of the deepest mysteries in physics, namely, the nature of space-time at the quantum level. As we navigate the currents of this philosophical and scientific journey, we find ourselves in a place where time is a constant companion and an exciting mystery. Whether it is fundamental or emergent, one thing remains certain: our quest to understand the nature of time is a constant pursuit, a quest that inspires wonder and curiosity. Why time exists? Some argue that time is a fundamental aspect of reality, an intrinsic part of the cosmic fabric, much like space. It's as if time is the canvas upon which the universe paints its ever-evolving masterpiece. Others, like the ancient Greek philosopher Heraclitus, saw time as the very essence of change itself. In this view, without time, there could be no transformation, no progression from one state to another. It's like the rhythm that gives life its melody. The illusion of unidirectional flow. The unidirectional arrow of time seemingly leads us from the present into the unfolding space that was the future, while simultaneously rendering moments into the past. This process is happening everywhere, all the time, and yet can be experienced in different ways from different perspectives. Some philosophers, drawing from the physics of relativity and quantum mechanics, challenge the notion of absolute time. Imagine time as a river with multiple currents, where events can flow in different directions depending on your perspective. From this vantage point, the unidirectional flow might appear as an illusion, a byproduct of our limited perception. In the end, time's arrow is not just an abstract concept, It's a profound reflection of our existence, a journey from the past to the present and into the unknown future. It's a reminder that time, with all its mysteries, is an integral part of our human experience, inviting us to cherish each fleeting moment and savor the beauty of the ever-unfolding cosmic narrative. Time, with all its mysterious qualities, invites us to ponder its nature in everyday life. This is why we remember the past, but not the future. As you go about your day, consider the mysteries of time that surround you. The ticking of the clock, the change of seasons, and the moments shared with loved ones all bear the imprint of time. Isn't that so? Share your thoughts about this by commenting below.